Hello, welcome to the first session after lunch. I hope you enjoyed the food, but didn't eat too much to fall asleep. So my name's Andrew Eland. I'm a software engineer. I work in Google's development center in Zurich in Switzerland, and I work on Google Maps. So I'm going to tell you a little about the Google Maps API and specifically the new features that we've been launching in it in the past couple of weeks. But before then, I thought I'd give a tiny bit of history of where the API came from and where it stands now. So Chris gave an excellent introduction this morning. It all really started with Craig's List, a website based in the US, made by a chap called Craig. It's a list. It contains, what most people use it for is apartment hunting. And as Chris said, another chap, Paul, reverse engineered it and turned that into put the Maps API inside a site that contained both maps and the listings from Craig's List. And this was really, really huge, because before you would go through the list, you would copy and paste addresses, you would move it across. It was just not a good user experience. And so we thought this would happen. It took us by surprise. And so we said, we need to make this actual public and real. And that's where the Maps API came from. So this is how the Maps API stands at the moment and has been since launch. It allows you to put a map inside a web page. This is a map. It's inside a web page. You can drag it along. You can do all the standard things that you can on Google Maps. You can double-click on it, and we'll center the map. You can toggle behavior. So you can switch from the standard double-click to center that we used to use to double-click to zoom. You can zoom in on bits pretty easily. So problems with using live demos at conferences with plenty of developers, little bandwidth. As well as the actual API, the maps itself, we try to expose all the features on Google Maps that you're familiar with to developers. So all the controls that you normally see and play with on Google Maps to move the map around, you can use and have control over as well. So the normal pan and zoom thing, that's available to you as a control. You can add that. You can use that. If you want, if it better fits your application, the smaller control that we use in certain places, you can do that. Map types, all the map types are available to you in the API. You can switch to satellite. You can switch to hybrid. And later on, I'll show you a couple of ways in which you can actually put your own map types on top. There is the scale as well. Very, very useful. Appears in the bottom left, lets people work out where exactly they are, good for the context. And the overview map. The overview map appears in the bottom right. Again, we added this because it's very, very important when you're browsing geographic information to have this idea of context. And quite often when you're zoomed in too far and in an area you don't know, it's really, really good to be able to see at a glance the kind of zoomed out view of where you are in the world. So that's why we put the overview map on the site, and that's why we make it available for you to use. And the whole system we use for controls, this kind of class hierarchy, is also available for you too. So that square up there, that's just a standard HTML div that we've put as a control on top of the map. As well as the kind of the controls that the map has, all of the rendering we do on the map to show it to the user is also available to you. So the nice little push pins that you see, they're available. You can just very simply add a push pin somewhere on the map. The reason why the icon is that way is we really wanted to kind of have a kind of feeling that you're dealing with a kind of 2D map and you're putting 3D physical objects on top of it. So that's why we have this nice kind of 3D effect info windows and the markers, and that's why we make them available for you so that you can use them very, very simply. So adding a marker is easy. Using the info windows that we have that pop up when you click on a marker, you can add those too. And we've done all the hard work for you, like the kind of shadows underneath it to give it this nice 3D effect. If you're the kind of developer who loves necessary complexity, I recommend that you kind of reverse engineer the code and look at how the shadows are implemented. It's pretty scary. That and also the tiny little shopping cart icon on Google Checkout, that's worth looking at too. So we have the markers, we have info windows, we have what we call polylines. These are the lines that we use to render driving directions, so we make those available to you. This is pretty useful for cross-browser compatibility because you have IE that supports one particular vector markup language it has. You have newer builds of Firefox that support SVG. You have older builds that can't do anything. So we have basically a generic interface that lets you say, I would like to draw a line on the map, and we choose the method of drawing the line on the map that's fastest and best for the user. And we expose that for you to use. And all these objects are just sat as overlays on top of the map, so you can add them, take them away, do whatever you want with them, really. Anything that you add to the map can respond to events. So we have some standard events that we support. For example, rolling over. If you have a marker, you can detect a rollover event and do fancy things with it. The map itself, also, you can hook and get it to respond to events. So for example, you can detect clicks on the map, which is a nice way if you want to add markers in particular places. If you wanted to build a kind of lightweight application that allows you to edit some geographic data, these are the kind of things you would be using. Likewise, you can do it for kind of more fun, trivial things where you can detect a marker on the map and move it around when you have the mouse cursor over it. Useless, but fun. So those are the kind of very core, basic things that any maps application will make use of on kind of day-to-day. There are some fancier things that some people use and are very useful for certain types of application. One is tile layer overlays. So this is basically using exactly the same infrastructure that we use to render between maps, satellites, and hybrid tiles. The difference is that we make it available to you so that you can use your own, serve your own tiles on top and add it as a layer. So this is kind of similar to a hybrid layer, but this is for Stanford University. And they have a nice, labeled high-resolution map, and so you can add it right there on top of the Google map. If you don't have something as rich as tiles, and you just have a particular image that you would like to place, you can do that too. So this is just one particular image. We happen to have geographic coordinates for the corners. You can just say, I would like to place this image on the map and put the coordinates at these positions. One of the newer, but not so newer features is support for feeds. So this thing here, this is a KML file. KML, as Ed said earlier, it's the markup language that Google Earth uses to display geographic content. This is actually a hiking route. I'm a very keen hiker, so I go out with a GPS, record all of it, and then you can pretty easily load your GPS track log into Google Earth and see where you've walked. So this is the kind of coast of Zurich. Here's the Lake of Zurich. Our office is right here. So you can see, you can make all these KML files, and as well as showing them in Google Earth, you can add them on top of maps. And equally, it will work for GeoRSS too, which is just a standard RSS feed, but with annotations of coordinates. So it's pretty easy to do that. We make it very easy to do things that seem very, very complicated to get your application up and running quickly. We also make some of our search available to you. So we have the geocoder that we use. Geocoding is the term we use for turning arbitrary text strings into places on Earth. So exactly the same as typing into the maps search box, you can put a similar search box onto your page, or any input you like. You pass a string to our geocoder, and it will asynchronously call you back and say, here's where we think this string is, and you can use it to implement address searches in your application. This is our office right here. So let's look at a kind of a fragment of what a typical maps application would look like. This is a trivial little function, hello, classic thing. It's going to say hello world at a particular place on Earth. So we have a function hello. It's referencing a global variable map. So Map is just a JavaScript object. You create one of them. It's of class gmap2. So you say map equals new gmap2 somewhere. That creates the map. And then you can just interact with it. So we pass this function a name, a latitude, and a longitude. We offer primitive JavaScript objects for dealing with the kind of geographic information in the API. So glat_long holds a latitude and longitude. You create one of those, and you can tell the map to center itself on a given position. So map set center, give it a lat_long, and a zoom level. So 13 is the particular level at which you want the map zoomed in. To add a marker, markers are pretty simple. We have a primitive JavaScript object for markers called gmarker. You can simply create one of those, give it a lat_long for where you want it to be, and if you want it to have a title so that when you click on it, it appears, you can pass that in too. And you add the marker as an overlay to the map. So the map accepts a number of overlays, and it manages them for you. And so you just ask the map to add this marker overlay. Then we want it to do something when you click on it. So we want it to respond to users clicking on it. We have an event handling mechanism built around this gEvent class. You ask the gEvent class to register a listener for a particular event on a particular object. So here we're registering for the click event on the marker we've just added. And when we do that, we're going to open an info window. So that fancy 3D info window you saw, it's just one line of JavaScript code, this open info window, and give it the content of the info window. So the content is just a standard DOM node. Here we're just using text. It could be anything. So if you run that in a browser, it looks something like this. So we can just zoom around the world and place markers down, and then when we get the hello Manchester and wherever you want if you click on it. So, I mean, this is a pretty small amount of code, so you can make pretty rich applications with very little work. So one of the other features that we just turned on a couple of days ago in the ever-expanding effort to bring everything on maps.google.com into your API is directions. So the way directions work is pretty much the same to geocoding. You give our directions engine a description of a route. So I have Zurich, Switzerland to Paris, France here. And you give it both the string you want describing the route and where to show the directions. So here's the control I said earlier, a custom control on the map. It's just a HTML div. You can ask us for the directions. We'll plot the route on the map, and we'll also give you the directions rendered into whichever elements on your application you would like. So the code for the directions is right here on the screen, pretty easy. The var pane, my pane, that creates the custom little control window you saw. So map add control pane adds it to the map and makes sure it floats on top. Then the directions is all governed by this gDirections class. You create one, you give it the map it's going to work on, and you give it a HTML element into which to render the directions. So typically that would be a div. Now, because directions take a while to process, it obviously has to be asynchronous. So you register listeners on the directions object. So you can listen for whether or not an error occurred, for example, and the API describes the errors you could get, for example, as not being able to find where the user wanted directions to. And then actually rendering the directions is just as simple as calling the load method on the directions class, and then that will render the directions into that div. We're letting developers do 10,000 queries a day before we ask them to politely ask us first, because all of these things, impacts our back-end servers. And so if you are going to do anything that is going to massively peak our directions system, we would like to know a few days in advance so that we could, make sure we have enough capacity for your application. So as well as directions, once you're doing anything to do with routing on your API site, it would also be good to see where is sensible to drive. And so we provide the real-time traffic information we have for some cities in the world. We allow you to do that in the API too. just as you can on maps.google.com. The code, again, pretty simple. You create a traffic overlay object. It behaves in exactly the same way as any other overlay that we have on maps. You can add it, and at some point later, when you want to take it off the map, you just remove the overlay from maps. This is one feature that I can't demo right now because it is not quite out. This is a very, very sneak preview of something we're going to be adding to Maps, the Maps API in the short term, and this is AdSense. You'll have noticed that if you do certain searches on Google Maps, like Hotel London, for example, in this case, you'll get our search results, but you'll also get some sponsored links, and they appear pretty differently, so you can tell the difference. There's a different colored marker jutting out opposite way to everything else, and when you click on it, it will show you a sponsored link. And we will allow you to add these to your Maps application if you want. Again, the code, once it's released, is pretty simple. You create an ads manager class. You give it your AdSense ID. You get to choose the maximum number of ads that would be displayed on the map. And you also get to turn it on and off. So this is something that you will completely control when we launch it. The reason is because we want to give people who develop these applications a way to monetize their applications. So if you put sponsored links on your Maps application, which is entirely your choice, if people follow through, then you will receive a share of the revenue. Now, since we released the Maps API, it's been hugely successful, and thousands of websites use it to organize all their information. Which we are really proud of, and we're happy it's been so successful. But as with all these things that evolve, you never know which direction they're going to evolve in. And so we've ended up with a user experience that isn't particularly brilliant at the moment. So let's say I'm an American, which I'm not, and I'm trying to find an apartment. I would go to a real estate website, such as Housing Maps, and I would find a house I was interested in, and then say, well, is it in a safe area? I could go to Chicago Crime and, say, well, I don't want to live around here. There's been, like, murders and things. And then you want to see if there's any good schools. So greatschools.com has a Maps application that will show you where the schools are. I'm not American, though. I'm English. So I find a flat rather than an apartment. I go to an estate agent, not a real estate agent. I don't look for crime. I look whether or not there's a good pub nearby on Fancy a Pint. And then I obviously have to find out whether or not there's a decent curry place nearby. Another case, finding a hotel. I go to last minute. I search for hotels. But then, I want to see whereabouts they are on the map and what's nearby. So then I have to go to Maps and then separately enter the address and look for directions to that hotel. It works, and it's good, but it's just tedious. There needs to be a better way. That's the first main problem. Here's another problem. You want your mashup to be successful. Here are the kind of typical traffic patterns you get of some really, really, top-flight mashups that are really, really popular. And here's the traffic on Google Maps relative to it. Really, if you want traffic to come to it, integrating with Google Maps is the only way forward. So that's our solution. Our solution that we've come up with is Maplets, and it's a way of bringing your mashups onto Google Maps itself. And it's available now on a developer preview version of Maps, maps.google.co.uk/preview. And what it is we've blended together two separate APIs. Google has a Google Gadgets API on the personalized homepage or on other blogs or on any website. It's basically an API that allows you to put an iframe on it containing some HTML, some JavaScript to display some interactive content. And we do some clever work behind the scenes to do caching and also to store user preferences, all these things. This lets you embed executable content onto other people's websites. And then you have the Google Maps API that I've just described, and you can add overlays to the map, and you can listen to events. So Maplets is bringing the two APIs together. It's allowing you to put executable content on top of Google Maps itself. So let me see if I can find a good demo for you. So, for example, the hotel booking. Rather than going to a separate site, we have a maplet at the moment from one hotel provider. I can ask it to search for hotels, and it sits there on Maps itself. It will go off and search for hotels, and then it can interact with the map, and it can display markers right there on top of the map. So then I can find a hotel that looks interesting. And then, because it's embedded on top of Google Maps, all of the standard features that you know and love about Google Maps are right there to use with it. So, for example, I can trivially get directions to this place now right there. I can search, from the airport to here. Because it's sitting inside Maps, and I can use the features that are there already. So, for example, let's look at something else. I mentioned earlier that I'm a keen hiker. So one of the things that I like to do is find decent routes to hike around. And to help with that, I built my own little maplet. So this is in the long-term, in the long tail of geographic content that Ed was talking about earlier. This is my own personal entry into the domain, if I can find Switzerland. Finally. Fun with bandwidth at venues. So I have a little maplet that allows me to take the GPS logs that I had earlier and then just display them and let users choose. So, for example, I could hike across the Surennen Pass. Maybe it's pretty nice around that area. Or I would maybe hike by the nearby mountain to the Google office, Uetliberg. Yeah, so this looks quite interesting, 22 kilometers long, sounds pretty good to me. But I need to get to the start of this hike. So I'd like to know how easy it is to get to. So I can add another maplet, for example, that will show the average travel times around Zurich. So here we have a second maplet. We combine the two together. And it looks like, yeah, it's certainly reachable from the center of Zurich. So it's looking pretty good. And then, because this is just the standard Maps application, I can use all of the features of Google Maps. So if indeed it is possible to get here pretty easily, then I would like to be able to know how. So I can zoom in all the way. And yeah, there is a tram stop right next to it. I can click on it, and I can use all the fancy Google features of telling me what tram lines stop there and when trams stop there, these kind of things. So bringing together all of these different pieces of content really, really helps the user. So that's kind of the vision. That's the kind of thing we would like to enable you as developers to build. How do you go about doing it? This is the sample code for a trivial maplet. It's the hello world example we saw earlier, but it's now expressed as a maplet. Basically, you have in the middle here some JavaScript code, exactly the same as earlier. It actually creates the map object. It centers it on a point, and it will add a marker and open the info window. It's wrapped in a little bit of XML because we need some meta information. When you put the maplet on top of Google Maps, we want people to be able to search for it, and we want to be able to find it, that kind of thing. And so we allow you to put the meta information describing what the maplet's called, who wrote it, what the intended use is, those kind of ideas. So here's a high-level architecture. You're all developers. When I say the word cross-site scripting attack, you know what I mean? Yeah, so adding other people's executable content on top of your website, not a very good idea. For example, you certainly wouldn't want somebody to write a maplet that in JavaScript stole all your cookies and went and read your Gmail. That would not be good. So we want to prevent users from doing that. And here's how we do it. Maps.google.com runs on maps.google.com. Your maplet runs in an iframe, and that iframe is served from a different domain. It's served from gmodules.com. And so anything that runs in a maplet cannot access the map. They're two completely separate domains, and so the JavaScript in one cannot communicate directly and can't play with the JavaScript in another. Therefore, you're completely safe from any kind of cross-site scripting. Gmodules.com also provides the functionality to download content from other domains, because of the same reason you can't access domains other than the domain you come from. We provide you with a proxy that will let you download content and use it. It also stores user preferences, so users can tweak preferences, and it gets stored on our servers, and they can refer back to it. So that leaves us with a problem. We have, for security, we have to keep the maplet on a different domain to maps.google.com. But they still need to communicate, because the whole point of this is that the maplet has to interoperate with the map and move it around and add markers. So how do we do that in a way that doesn't allow executable content to run on maps.google.com itself? So what we do is, we at Google, we like distributed systems. So we look at this as like a distributed system. Just like you have two computers that are connected by a network talking to each other, you have two different iframes, and there is a small distributed system. They're served by different domains. They can't talk directly. So we build a remote procedure call layer on top of JavaScript that would let your maplet communicate with maps.google.com. So it works by every time you make a JavaScript call on the map. So when you say map.setCenter and then give it a latitude and longitude, just like you would do in any kind of, say, Java RPC or something like that, you serialize that call out, so you turn it out into a string that describes both the method that you want to invoke, the object you're invoking it on, and the parameters that are passed. We then create an iframe, and in that iframe, we go to some web page in maps.google.com, hash, and then we put the serialized call into the fragment part of the URL. So the iframe loads up, it gets some JavaScript from Google that can read the URL, and it extracts the serialized call from the URL, unserializes it, and then calls that method on the map. So we allow one piece of JavaScript in one domain to call methods on a piece of JavaScript in another domain without introducing any security holes, because we completely control the calls that go on. One good feature about this is all the communication takes place within the browser. After you make the first call, every time you create this iframe, you're going to the same URL. You're just changing the fragment at the end, which means the browser doesn't need to download any extra content in order for this to work. So it's pretty fast and efficient. So there is one problem with doing this RPC-based approach, though. When you make and serialize this call, it's obviously not going to be immediate. It's going to be, the first time you do it, there's going to be one server round trip. From then on, it's OK. But you're still going to have to go through the serialization, deserialization delay. Now, you know there are different ways of dealing with this. You could use multiple threads. You could use asynchronicity. In JavaScript, we don't have the threads-based approach. We don't want to block the browser up. And so we go down the asynchronous approach. So the API that you use in Maplets is almost identical to the API you use when you're using maps.google.com. The difference is that any call that would return information to you can't return immediately, because it has to go through this RPC mechanism. And so to do that, we do the standard-based approach of giving a callback. So in the normal Maps API, you can say zoom equals map.getZoom, and that will simply return the current zoom level of the map. In the Maplets API, we can't return it immediately. We have to do it asynchronously. So we have getZoom async. You pass in a closure, and then that will be called and passed in the zoom level. And then you can do whatever you want in that function that you would have done anyway. So to differentiate this, we've added new methods to the Maps API that for every method that returns a result, we now have that method and that method with the word async appended onto the method name. And that's an asynchronous version of the method that will work in the Maps API, in the Maplets API, sorry. There are a couple of other security restrictions compared to using the normal Maps site. your maplet can't change the default behavior of the map. It would be really, really annoying if you had a maplet that loaded and then decided to change the way that double-click worked and then remove all the map types. That would not be fun. So you're only allowed to add things to the map and add content and things. You can't change the fundamental behaviors of how the map works anymore. We don't allow any JavaScript to run in the maps domain for exactly the reasons I said earlier. That would be a breach of cross-site scripting. And the info windows that pop up are obviously in the maps.google.com domain. That means that anything in info windows can't contain any malicious JavaScript or CSS. If it does, when we display it, we'll sanitize, we'll strip out all the JavaScript and CSS before we open the info window. This is a limitation in some respects, but it's easily worked around, because what you can do is inside an info window, you can open an iframe. And that iframe can be served from a completely different domain, and once you're in your own iframe, you can do whatever you want. And indeed, the iframe could itself be a Google gadget. You could embed a Google gadget inside the info window of a marker on maps, and that would be fine. So here's a short design pattern that is kind of unrelated in some respects to maplets, but we'd like to take kind of to impart to the maps developers. Many Google Maps API applications look exactly like this. You have geodata at the top in a JavaScript array, some lat longs and some names. And then you run through that data, and then you add an overlay for each piece of data. You add a marker, these standard things. This works well, but the problem is that you're locking the data away inside your application. Nobody else can see this data, really. It's buried in JavaScript. It's hidden. It's hard for people to build on top of what you do, and it's hard for people to discover the content in your Maps application. So there are ways around this. Instead of embedding the geographic data in your application itself, we can use a standard format and keep your data separate from the application in a standard format alongside the application. And so we support, as I mentioned earlier, KML and GeoRSS. If you have any data, you can add that data as a KML file and as an RSS file. And you can very simply add that data on top of your Maps application. So it's easier for you as a developer. But what's also good is that we now crawl KML files and GeoRSS files along with web pages. So we crawl and index that content. And so if you use maps.google.com and search, we will index and find any content available in KML files, which means your content gets out to more people. You free the data from being embedded in JavaScript code, and you get it out there for people to use and play with. And if you don't believe me that it's simple to do this, here's a simple KML file that encodes the data we saw earlier. A simple document. You have place marks being points on Earth. They can have names and coordinates. The KML specification is very, very rich, but for simple tasks, it's pretty simple. And embedding it in your application is this. The hiking route I showed earlier, that's the 2 lines of code necessary to display it. So all to do with rendering the lines and adding the markers and all the standard stuff which many applications have to go out of their way to do can be encapsulated very, very simply if you just leave all the rendering to us. And the rest of this slide intentionally left blank. How maplets fit into the bigger picture, because we have lots of different ways you can get user content on maps, and so it's and use geographic data with Google. So it's good to step back and say, well, how do maplets fit into all this? My Maps is a very kind of basic way of sharing geodata. Say you're organizing a party or something like that, or something very simple. You have a small amount of geographic data you want to quickly put on the map and share with people. My Maps is the way to go that. If you haven't seen it, it's a kind of lightweight editor built in top of Maps itself. You can go to My Maps, you can drop markers onto the map, draw lines, and then share that with somebody else. It's actually what you're doing behind the scenes is you're building up a simple KML file that could then be used in Google Earth, but then we store it and then we let you share that content with other people. If you're doing something more complicated, if you have a lot more geodata to display, It's generated dynamically. For example, you have some script on the server side which trawls the database and spits out information, or it updates dynamically, so you want real-time content. KML is the way to do that. It allows you to describe pretty complicated geographical features, and it allows you to refresh this data on demand, lots of fancy features. KML is the way to actually encode and show that information. If you want an interactive user interface, if you want something where the user can actually add it to maps and play with it, Maplets is the way to go. And you can back your maplet with data stored in KML behind the scenes using the overlay I just showed. But if really the benefit of maps is allowing you to add the user interface on top that allows you to do kind of complex and domain-specific searching. So what we can do is show a tiny demo of making a maplet. So we had the Hello World maplet a few slides earlier, I believe. Yeah, so here we have the Hello World maplet. So the life cycle of making a maplet goes something like this. You sketch out the code like this, and you can save it in a standard editor like this. Here's the code. And then you need to put this XML file available somewhere. So if you have a standard website, I can copy this across, providing we have enough bandwidth. So I shall SCP the maplet across. Let me just make sure that works. Let me see. So it should end up somewhere on my personal website. Yep, here we are. There's the XML I just copied across. So we have the XML. Now we have to integrate it into maps. So to do that, we can go across to the Maplets tab on maps.google.k preview at the moment. We have a link here, information to developers. That will give you the specification, much more detail than my overlay. But we can say add content. And that will take you across to the Maplets gallery. So it's very similar to the Google Gadgets gallery because Maplets are basically Google Gadgets for maps. So it's built on top of it. You can say add by URL and just plug in the URL of the maplet you would like to add. So we just had .org hello world.xml. And so at this point, we go off, we fetch the content from your website, we pull it back, we ask you to to confirm that you are adding third-party content to maps. We add that to the maps, and then when you go back to Google Maps in your list of maplets, we will now have, Hello World, here we are. And if you turn that on, it'll run the Hello World example we saw earlier. We have a div, it's rendering the information into, placing a marker, centering the map. So it really is pretty simple. You can learn much more about Google Gadgets if you go to the talk later, the technology on which Maplets is built on. It does pretty aggressive caching, for example. So when you add one of these maplets, what we'll do is we'll fetch it from your website, and we'll cache it on our own servers. And then when people add it, it will be served originally from Google, not from your site. There are two benefits to this. One, it's faster for the user if they fetch it from our site. Two, if you have a maplet that suddenly becomes really, really, really popular, and we all hope you make maplets that are really, really popular, but if you do, we're basically going to denial of service your ISP. If you have millions of people in the world all loading your maplet, your ISP is not going to be happy. So that's one of the benefits of us caching it, is that it will be served from our cache, and your server will not be attacked by the onslaught of people wanting to look at it. And this goes for data too. If you download data within your maplet, we'll cache it as well, and we'll serve it. And the hiking example I did earlier is just as simple, really. Just as simple as creating here a geo XML overlay and choosing it from a list. So that brings me to the end of talking about new features on maps. So I'd just like to plug, there's a session later on, 4:45. this room about Google Gadgets. It's the framework on top of which Maplets is built. And they'll go into some more detail about the kind of features that Google Gadgets have, and most of them are shared by Maplets. And if you want to get out there and try developing these things right now, it's available, maps.google.co.uk preview. And with that, if anybody has any questions that they'd like to ask, I'm happy to answer. Or if not, that's good too. There should be mics being brought to the front right now.
Can you tell me, does the Maplets API support custom tile layers?
As far as I know, yes, it does support custom tile layers. I would have to check in detail. I think it does. Yeah, pretty much. The APIs are almost exactly the same. The only things that we can't put on there is things that currently requires running arbitrary JavaScript in our domain.
Thanks.
Questions about disambiguation of search results?
Yes.
I know that on maps.google.com it isn't there. So if you look for Smithfield in the US, you will only get one and not many. Yeah. Or Sutton in the United Kingdom. Is that available through the directions API at all?
Yes. So you're asking what happens if we can't disambiguate the address?
Yeah.
Yeah, so what will happen is if we can't disambiguate an address, you'll get a callback with an error saying we can't disambiguate this address. So how we do it on Google Maps itself, if you enter driving directions we don't understand, then we will give you possible options and you pick from those, and then we calculate directions through that. So if you wanted to do something like that, you could build exactly the same thing into your API site. You can use our geocoding API to take the input from the user, find that, and then once you have a source and a destination that the user is happy with, you can then pass that lat long to the directions thing, and then we'll give you directions there, and that removes any disambiguation. Okay. We don't, at the moment, provide any kind of way ourselves of sorting out the disambiguation.
Okay, so you just have to add the right event listeners for it.
Yeah, pretty much you'd have to implement it yourself, the kind of refinement.
Also, just about My Maps, you said that when you do save points using My Maps, it creates KML files at the back. How are they exposed? Like, how do you share them?
Let's have a look. If we go to Maps, and then you can go to My Maps. You can tell it's the end of a session. The wireless bandwidth. I would like to see graphs of wireless bandwidth usage against time. That would be pretty cool. Create a map. Or perhaps not. It may be too slow to do this right now, in which case we can find perhaps a map that has already been done. I can do it with some KML file because that's exactly the same. That should work, I think. There's another feature. If you if I can find a KML file that actually exists. This one, perhaps.
Save to map.
Yeah, right, here we are. Yeah. So a small feature that maybe you didn't know about, you can enter the URL of a KML file in the top, in the search box, we'll render it. Cool. So what happens is you get a little KML icon here, and this will appear if you have a My Maps map as well. So the icon will be there. If you click on it, then it will give you the KML data back. And so if you create it yourself, it's the original content. If you create it with My Maps, it will be the KML file that we've created behind the scenes for you to go off and edit.
Oh, okay. So it's not that you can automatically share. You know how, because KML files are cataloged by the Google search engine, are the My Maps automatically cataloged, or is it something you have to pull down and host?
No, the My Maps are automatically crawled. I mean, we crawl all the KML files we know about, and we know about the KML
My Maps as well.
Yeah.
Okay. Cool, thanks.
Hey, Andrew. Does the AdSense integration extend to the Maplets interface?
Does the what, sorry?
The AdSense integration?
The AdSense integration. Yeah. I'm not sure. I imagine it won't because we have our own AdSense on top of Maps at the moment.
Okay.
So certainly when we launch, I'm pretty sure it will only be available in normal Maps API sites. When we go forward, I don't know what the future direction will be.
Okay, thanks.
So the shadows are really pretty looking, but the problem is that if you want to make custom markers, it's an absolute nightmare making shadows to fit them.
Yeah,
Are you going to give us some kind of tool or something to make that less painful?
Yeah, so we have a tool inside Google called UI designers who really love doing all these shadows and this kind of stuff. I don't know, it's the first time I've heard of such a feature. That's a pretty interesting feature, and yeah, that maybe. You could imagine, having some URL that just served a shadow dynamically based on fetching your graphic and assembling it and then generating a dynamic shadow. That would be pretty cool. Okay.
Oh, and My Maps is great, but the URLs it generates are horrific. Like, give us something we can read out to our mum over the phone.
Yeah. I guess the answer there is you can use one of the many URL shortening services. But yeah.
Howdy. What can you tell me about the size limitations of KML in Google Maps, as far as number of points and file size?
I have no idea, I'm afraid.
We've been trying to plot 24,000 points on Google Maps using KML, and so we're looking at nesting the data into network links.
Yes, into the network links, yeah. I can't remember if network links are supported in KML on Maps right now.
Well, it appears to be partially, but it's not view refresh mode, or?
Yeah, it's I think certainly the sort of KML that you can display on top of Maps right now is pretty simpler and less rich than the KML you get to see on Google Earth. Maybe the best way for you to go is to use either the Maps API and have full control, or if you want it on maps.google.com, is to use a maplet, and then you can implement the dynamic loading yourself, and then you have much more control over the kind of events that happen.
Right. And as far as caching of the KML on your servers, how can you clear that if you need to update your data?
So if you need to update the data, I'm pretty sure that our caching system responds to the standard HTTP caching headers. So if you set an expires header, we'll probably respect that.
Okay, great. Thanks.
If you have several maplets and they add event handlers to the map, they want to know when you click on the map, how do you disambiguate several maplets receding?
If you add two maplets at the same time, they can all add data. So we have the hello world one that has a marker, and if I add another one, you'll see that in the bottom left, although more than one is visible, only one gets to use this panel. And so the thing that currently is using the panel is the one that responds to clicks. Okay. And then you can swap between them just by clicking on it. Okay. So you can have many pieces of content on screen at the same time, but the map itself is only the kind of focused maplet, if you like. Of course, if your maplet adds markers to the map and you click on them, then you always get the events to that, independent of whether or not it's focused.
Thank you.
I think I'm running out of time, but if anybody has any more questions, feel free to find me later and ask me anything about maps. So thanks for listening.